and welcome back to Think Code and More. So today we're actually going to be doing that science project I've been telling you guys for a long time. Funny thing is that me and my dad, have been
Yeah.
thinking of doing this project for 2 years now. First we saw it in like a small shop, and I'm like, Dad, should we buy it? And then my dad's like, no, we should make it. And then just after 2 years, now we're actually doing it in a video. And we never did it before. We just tested it out a little before this video, and let's just get to it. So what we're going to be starting off with is just looking at how I made these small little iron pieces. So I took this string that you can buy at like the dollar store or whatever, and cut it into these small pieces with pliers
Yeah,
or like whatever,
we used a scissor
scissors.
or a plier.
Yeah,
Anything can work.
anything that
Anything
can.
that is safe
Yeah,
for the kids.
and then we had some magnets that were here for a long time, since those 2 years. I think even longer. And we just have this magnet. We're just gonna take it up and look at what we have. We have, you could say, just a big giant claw.
Yeah,
Or-
or a magnetic arm.
or a magnetic arm.
Yeah, it's flexible too. Yeah.
Or you could like say it's a chain. I mean, if you see it, literally the
Yeah.
magnet, it's connecting all of these little pieces. And if we have this,
And you see how it can bend?
so I'm gonna put these pieces right here. You can just collect that.
Yeah.
Yeah, also here's a small tip for cleaning up all of this. Just take the magnet, hover over, oh, right there. Just hover over everything, and then it will just pick it all up, and then you can put it back. So here, we're gonna put this a little bit lower. Here we have a little bit stretched, and just imagine this is not here, it's a flexible arm. Now it's literally taking everything.
Yeah. Since this is a bigger magnet and that's a smaller magnet, it's the power of that magnet is less. So if you add one more magnet to that magnet, then it will become stronger. Right? And now try to pull this.
Wait, let me put it sideways.
Oh, it's strong. It's getting stronger and stronger.
So these strong magnets, and what they're doing is just collecting all of these little I always call these little pieces magnets. No, they're collecting all of these little
See
iron pieces.
how this is picking? The arm is picking the rest.
And also, what I meant for just hover the magnet over everything. Magic. It's all cleaned.
And let's connect the arms together.
Doo-doo-doo. So now this is mainly what this project is for, or is to talk about. But there are a few more theories and things we didn't know that we tested out before the video, and we would like to show that to you guys right after. So what we're going to be doing now is testing out how the magnets and the iron react differently or the same in water. So you can pour in the water. Okay, now we have some water, and now let's put in all of those magnets.
The metal pieces.
I always say magnets. Why do I always say magnets? I do not know. So right now what I'm doing, putting all these little pieces of iron in this glass, you could say, cup. Okay, so now what we have is all of those little pieces are inside the cup, and we're just gonna see if this
Yeah, we have to see if the if
magnet can
magnet can
actually
even
move.
yeah magnet can actually work when thing is inside water.
So
And there is
we
glass also. We have to consider the glass is thick,
yeah.
right?
So this is pretty thick glass. Let's see if the magnet can still move the iron pieces. And it can. Now another thing is that you can also just leave it
And
right
it
there.
makes a different shape though.
It does make a different shape when you're moving it. It like sticks out more, but when it's regularly on like a surface, not inside water, it just moves. Like if,
Oh, this is what shape did it's making? It's like spikes,
and also another thing you
spikes
can
in
do,
water.
keep this on the bottom, magic.
Yeah, that's cool.
What magicians do is use magnets. I mean, if you see MAG in the three
Right.
letters,
The first three letters are the same.
yeah.
Okay, let's see
Okay, so we see this now.
what shape is it making. It's
It's
making
like spikes of the coral reef or something.
yeah, that's what.
Now let's just see the next part of this, which is oh wait, that's cool. When you bring it here,
Yeah.
so the next part of this, we're just gonna hover this magnet above this cup. It is not attaching the little piece of metal, like a centimeter in. Nope. Touching the water. Nope. A little bit in the water. It starts to.
Oh, that's a robot. He's a robo shape.
Well, yeah. It's like so. Maybe when it's technically in or outside. I mean, yeah. So when the little pieces of metal are inside water, then the magnet has to go closer to them to make those little pieces attach to the magnet.
So its power reduces as you see objects. It doesn't matter like whether it is glass or whether it is water. Actually, that would be cool. Like, how much difference does it make? Yeah, that's cool. So let's see. So if we empty this water and see how far do you have to go down?
So
The,
I'm just gonna
so
take
let's
like a
see if you go down.
yeah, yeah. Oh, you just dropped it all in there.
Oh, with your hands, I think it was working much better.
Okay.
Go.
What was that? Pouring it all in. And also, like when you take it out and you might feel like, oh, it's wet, you need a paper towel. It's not that wet, so I mean, we still had a paper towel just in case because of this small experiment we're doing. So here we have almost every single uh, metal piece back in. There we go. Well,
So
they're just
imagine
coming
if
out.
you have a lot bigger magnet and then you had a lot of these pieces and the magnets are just revolving around a container, right? Containing these metal pieces, a transparent container, and
Yeah.
it's constantly making different shapes,
I mean, yeah,
right?
yeah.
Yeah, that's good.
Well, also, let's just take like a mental marking of where the magnet needs to be to collect the metal. Okay, so right there, the magnet slipped from my hand.
Oh, okay. So I'm not the only one,
Yeah, you're not
but
the
you
only
got
one.
all the pieces, so that was cool.
So
Let me
right
take the
there,
water out,
I put a mental marking.
and let's see now what happens.
So the mental marking is there. And now we can put in all the magnets again.
Does magnet get stronger when it touches water? No.
I wouldn't think so.
Yeah, that's the whole point. So it doesn't matter if it's water or if it is any other thing. It may because the density of water may be less than the density of the glass. So let's see. So do now.
So we have that mental marking right there.
Oh, it didn't make a difference.
Yeah.
That is strange.
It almost felt like I had to go closer.
Closer.
Or maybe it's because these little iron pieces were in the water, so they're wet.
Oh, we can dry them up.
Yeah.
But that was something.
That was
Yeah.
interesting. So let's dry these little magnets up. Maybe like dry the. I still have the mental marking memorized. It's this small line right here. So I'm just gonna dry the glass.
Yeah, dry the glass of water.
Oh, there's still some metal.
Okay, I'll
Come here. Take the metal. It's over there. Yep, it's all clean. Okay, now to dry cup also. Had that mental marking. It was right there. Now you can put it all in and see if it makes a difference.
Okay, you go ahead.
Taking the magnet. The magnet is also dry now. I'm going to put it in. Okay, so right now it's not surpassing. Ah, it's because the iron pieces were wet.
So do you have to go closer or?
You can go further.
Oh, so the distance is the more and it attracts, right? So it means water did reduce the magnetic effect.
Yes.
Okay, so that was the conclusion
of this video. And now we can just move out to the outro. So let's go. So make sure to leave a like and subscribe for more videos about iOS development. Now we have science projects. So in the next science project video, we're actually going to be inviting my high school cousin. She was in our other video for math, why the cosine of 90 degrees is always 0. And she's going to talk about why do magnets only attract metal and other magnets? Why not like plastic or glass or like maybe paper? Well, paper is made out of trees, so wood. You could say why it doesn't. And that's what's going to be said in the next science video. And a game is coming very soon now.
Awesome.
Yeah. Very soon now. So stay tuned for that, and bye. So another thing that happens with these magnets is that you can take the magnet and put it like in this small container, we could say, and move the magnet around the sides, and it's technically like shape shifting.
Yeah, can you do that? So now do it. So this way. Oh, yeah. I think from the side of the magnet it works better. That's another thing we have to look why. So you can make a shapeshifter using magnets.
Yeah.
Oh, cool.
And let's go on to my dad's part of the video.
So let's learn like what's going on, right? So there is, why do these magnets are sticking together, and what's the reason like these magnets are attracted to each other or they attract the metal? So there are two poles on Earth. There is the North Pole, the South Pole, and think about those are big magnets. So each of these pieces of magnets have a north and have a south. Whenever this magnet attaches to each other, So the North Pole is getting attracted to the South. So North and South get attracted. But if you try to do the North and North, right? North and North, you will see that it's going to always flip because it's trying to go back and see how it's moving, and it jumped out of my fingers. So it moves, right? Right here. So it's trying to get to a point so that it's the north and the south, the opposite poles are in front of it, right? In front of each other, and then that's basically is the normal tendency of the magnet to connect. But anytime you're trying to do the north and the north or the south and the south, they will repel each other. They will move away from each other and try to go back.
So that is it for that part, and let's move on.